Hi, Set 6. I have a little bit of a video answer key for you for tonight's homework. There are 3 problems I posted to the e-board. It was to find the equation, the exponential equation for three equations given given pairs of points. Okay, so for problem 1, it was a kind of an easier problem. I gave you 2 consecutive points. Problem 2, a little bit harder, and problem 3 was the hardest problem. All right, so here I go. For an exponential function, you're writing them in the form y equals a times b to the x. A is the y-intercept and b is called the multiplier. Okay, so for problem 1, up here I have the 2 ordered pairs, 0, 4, and 1, 15. I made a table here. So just to remind you, the multiplier is the value that y is being multiplied by for every increase in 1x. So here, because we're given consecutive points, x is 0 here, x is 1 here, we know the multiplier is really just whatever you multiplied 4 by to get to 12. So I wrote a little equation. 4 times the multiplier is 12, and solving it, we get the multiplier is 3. Okay, generally, you just start with the first y value, and you set that number times the multiplier b equals the other y value. Now, if there's more than one jump between the 2 x values, we have a different situation. But if they're just consecutive values, simply the first y value, 4, times b equals 12. So b is 3. So the equation, again, y equals a times b to the x. So in this case, it's y equals 4 times 3 to the x. And this is not 12 to the x. We don't multiply those, okay, because of the PEMDAS rules. Problem 2, we're not given consecutive points, but we are given an a value of 7. A is always the starting value. And then we've got to figure out the multiplier. Now, from 7 to 28, that is 4, right? 7 times 4 is 28. But 4 is not the multiplier because we're not given consecutive x values, okay? Set up a little table and then ask yourself, well, 7 times the multiplier would give us, well, where x is 1, so we've got to use the multiplier again to get where x is 2. So 7 times b squared, 7 times b is 28, all right? Solving that equation, we get b squared is 4, so b is plus or minus 2. Okay, if this was a real-world scenario, maybe the negative wouldn't make sense, but this is just a math problem, so we should consider both cases. The multiplier could be positive or negative, okay? Like this next term could be 14, and then times 2 again is 28, or it could be negative 14. Right? 7 times negative 2 is negative 14, and then times negative 2 again will give us the positive 28. So 2 multipliers are possible here, positive or negative 2. So we have 2 possible equations. All right, the a value is 7, but we could use a multiplier that's positive or negative in this case. All right, that will happen when you have a b squared equation. All right, now the last one, I give you the a value here too, which is 10, but here we've got to go from 10 to 60, and we have 3 jumps, right? 0, 10, and then all the way to 360. So we got to apply the multiplier 1, 2, 3 times, or 10, that first y value always, times b to the third equals 60. 10 times b to the third equals 60. Divide by 10, b to the third equals 6. So b equals the cube root of 6, which I have written as 6 to the 1/3 power, just because it's a little bit easier for me to use equations with that kind of an exponent, okay? So we have the a value is 10, and then we have the equation like this. Okay, if the cube root of 6 is your b, I'd like to write the equation as 6 to the 1/3. So 6 to the 1/3 x is 6 to the x over 3. Okay? You also could write the equation, though, just as 10 times the cube root of 6 to the x, if that's easier for you. Or you can get the decimal approximation on the calculator. Now be careful with this last one, though, because if you use this rounded value, then if, say, I ask you, well, find the value of y when x is 20, well, your value is going to be different than the true answer because of your rounding. So be careful with this. Use the ugly decimal. Don't round the calculator's value. But on the paper, if you want to write this rounding, that's fine. Okay? So hopefully this was helpful. And I'll see you guys in class. Okay? Bye.